As the first problem suggests, try using your calculator to solve this problem. You can pull up your TI 84 calculator. I believe the 82 and 83s also have the stat button. So go ahead and take your calculator and go to stat, and we want to edit the list. So what we're going to do here is we're actually going to put in all of these numbers right here, nice and quick, punch them all into your calculator. We want to find the median and do some one variable statistics. Now the median is the middle number. So when you think about it here, we have 11 numbers. So it's actually going to be the sixth number when we put them all in order. So right now the numbers are not in order. So if I pass the sixth number, we have not actually found the median. I have to move the calculator so we can see the rest of the numbers. But the middle number would be the median. So the median is also known as the 50th percentile. So go ahead and take a moment and punch them all into your calculator here. Try not to make any mistakes, and that's why doing it by hand is also a good idea. So we're getting near the end of this right here, putting all the numbers in. Last but not least, once we have all the numbers in, and we know we've put in 11 because it says list 1 has 12th, we're on the 12th position, which there's nothing for that. We have all 11 in. Let's go to stats. Let's go to calc and do one variable statistics. Now by default, it's going to do list 1. We could choose list 1 by going to second, list 1 right here, but it would have done that anyways had I hit enter. And on this screen right here, we will be able to get the median, just scrolling down a little bit, and the median is 45. And it's just by chance it happened to land near the middle, but it is the middle number if we were to put them all on a number line. Find the quartiles. And this is where it would be a lot trickier. If you have 11 numbers, you can find the median and then break the lower half into, again, doing the median and the upper half into doing the median. I would not suggest finding the quartiles by hand. Your best bet is to use the calculator, which is going to give you Q1 and Q3. It's important to note that this is the 5-number summary here, the min, Q1, median, Q3, and max. The 5-number summary is just telling you the position at 0% of the data, 25, hence 1/4, median, 50%, 75%, hence 3/4, and the max. You can just think that you're adding up quarters here. 0, 1, 2, 3, 4, and that's the percent of data you've gone through. At 0, you've gone through 0% of the data, and through the 4th quarter, you've added up 100% of the data. So we have the Q1 and Q3, 37 and 54 respectively. There we go. And I really suggest using the calculator for these things. It makes it a lot easier, and you can use your TI calculators on the test. I highly suggest doing that. So let's go back to our stat list and edit in this list right here. Another thing you can do that makes your job a little bit easier is go to the top of the list, hit clear and press down. Don't delete your lists. I might have to make a video on how to put the lists back in if you've deleted them, but don't delete your lists. And so I'm going to enter in the numbers right here. Now, once you've entered in all your data, it's always good to check to make sure you've not entered in too much. It's a common mistake, and to check the numbers, you'll see it says list 1, I'm on the 11th position. There's 10 data points to enter in here, and now we need to find the mean. The mean is simply adding up all the numbers and dividing by the total amount of numbers, which would be all the numbers added up, divided by 10 here. And we don't need to do that by hand. The calculator will do it for us under one variable statistics. And I just hit enter right here, and it'll run the one var stats. The mean, which is denoted by x bar or y bar, because it's just calling this variable x. Sometimes we call it variable y. The bar on top of it just means mean of that variable. And it is 965. And it should look to be about in the center. You can see there's like 550 and 1350. Depends on how the data is skewed or not, but this data is slightly symmetric. We haven't graphed or anything, but maybe. The median price, that would just be putting all the numbers in order and then finding the middle number. But remember, we have an even amount of numbers here. But lucky for us, there's a lot of 950s, and apparently these 950s were in the middle when we put them all in a number line. That means just put them from smallest to largest and look between the 5th and 6th number. You can use the formula n plus 1 divided by 2, which is the number of observations, 10 plus 1 equals 11, divided by 2. That'll get you 5.5. That means if you put all the numbers in order, you would need to average the 5th and the 6th number to find the median. So the fifth and the sixth numbers had to have been 950 because averaging both of them gets us 950. Q1 is the 25th percentile, and that is 900. That is when we've gone through 25% of the data. Finding that by hand is not fun. It's not impossible, but there's different methods, and I just prefer to use the calculator. 1150 is when we've gone through 75% of the data. Now, it's important to be able to interpret these numbers right here. These numbers are 25% of the data is below 900, 75% of the data is above 900. At 1150, 25% of the data is above 1150, 75% of the data is below 1150. And a lot of times on the test, you will have to do this in context of a problem. So this problem says, here are the costs of 10 electric smooth top ranges rated very good or excellent by a consumer magazine. So you could say 75% of the smooth ranges, electric smooth ranges, are priced at or above 900 in this data set. So you look at Q1 right here, 75% of the ranges that are rated excellent or good, very good, are priced at or above 900, because this is where the divide is for Q1. The range of the distribution of prices is, and this is just max minus min, and we can look here at the calculator to see the max and the min. A lot easier than trying to scrub through the data. 13 and 500, 1350 and 500, 13 and 5 have a distance of 8. So if you subtract max minus min, you will get 800. The IQR is the same concept. It's good that these two are next to each other when we do them, because the IQR is just the interquartile range. Now the interquartiles are the middle 50%. Think of 2 quarters, interquarters. So 2 quarters is 50% of the data, and thus we are looking at the range of the middle 50%, which is 250. If you notice, Q1 to Q3 is 50% of the data, as in the 25th to 75th, 50 right here, 25th to 75th, and the range of those numbers is 250. So it's just the range of the middle 50% of the data. It's all the interquartile ranges. We have a stem and leaf plot, which is just like a histogram. I love these because you can see the numbers. So I look at this and I think to myself, okay, we got a little bit of a skew. We've got unimodal, and that might be an outlier. It's hard to say, but it is definitely unimodal. Unimodal means one mode. Uniform means one form. Think of a bread box, or like this button. This flatness right here on top of this button is uniform. Where if you notice up here, this has a mode. It has a peak. So modality, mode are all about peaks or humps. And bimodal would have to have 2 peaks. We definitely only have 1 peak there. Going on, is the stem and leaf plot display symmetric or skewed? Now, if you notice, and this is when people get wrong, people just drop this right here, and they say, it's skewed to the left. Nuh-uh. It is skewed to the right, because the numbers go to the high side. If you were to put this on a number line, you would think 0, 1, 2, 3, 4, 5, 6, 7, and think 7 trails off to the right. So if you just plop it down, the numbers are a mirror image. So that's a very common mistake people make. Another thing worth noting is the bin width here is 10, I believe. Yep. Here's the key, 7-2 equals 72. Always important to note with the stem and leaf plot what we're actually looking at. So with this in mind, each of these bins have length 10, as in this would be numbers 0 to 9, 10 to 19, and so we have bins of length 10, and this is a right-skewed distribution. The center of the distribution is and it looks to be in the 30s, probably. Let's see what we have for choices, and bada bing, bada boom. Always best to take a guess before looking at your choices, kind of sees if you're on the right track or not. The number of home runs per season range from a low of, and this is just seeing if you can read a stem and leaf plot. The lowest number here is 7, and the highest number here is 72. So the total range is 65. And just make sure you understand that each of these are a home run or home runs in a season by Mark. So this guy, Mark McGwire, maybe, who knows? Maybe it is Mark McGwire. No, I think he went to later seasons. I don't know baseball well enough. Someone is cringing at me right now who actually knows baseball. So at least I know the name Mark McGwire. But this would be a season right here, each one of these observations. So if you count them, I think it might tell us, it doesn't tell us how many seasons there are, but you would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and there's the 14 seasons right there because you'd count 1999. You started 1986. So there are the 14 seasons that they played, and that's the range of what they had. Continuing on further, which of the following best describes any unusual features? And this one might be, let's see here. An unusual feature is the 7 home runs Mark got in a single season. I think that's decent enough to say an unusual feature. Let's give it a shot. Yep. I wish it would have been, let's look at that again real quick. I wish it had been a little bit more of an outlier. It's kind of, it's close-ish. You think about how far it is away. It's 15 away from that, and this is 8 away. It stands out. Anything that's an unusual feature would stand out. Gaps and outliers are what we usually talk about when we talk about unusual features. Okay, this problem, people hate it, but think about what you're looking at here. You're basically looking at a histogram. All this is a histogram without the little scale on the left, a count frequency scale or a relative frequency scale. And you yourself can reconstruct this just by kind of looking at the data. I have 2 1s. So let's see here. You see there's 1 and 1 right here, and then there's no other 1s. So it could be this one, or this one. I have now narrowed down my choices. And this one only has 1 5. Is there only 1 5? Nope, there's 2 5s. See, there's 5 and 5, and there's two 5s in this one, 2 5s in this one. This one has 4 3s. Let's see. 1, 2, 3. Nope. So it's got to be this one. Just kind of a process of elimination right there. Make sure you look over it, make sure it has the right amount. Each of these dots has a count. This is called a dot plot, and it's just like a histogram. It's just we have dots instead of heights of blocks. Nothing too crazy here. What is the shape? This one is uniform. That's a uniform. This is unimodal skewed right. This is bimodal skewed right. Uniform symmetric. This is unimodal skewed left. Bimodal skew left. So ours is unimodal, and it might ask me about skew next. And I think I said it was skewed to the left. Just so we can see it again, I'm going to pull the screen back up. This is skewed to the left. Definitely skewed to the left there. Skew is whatever way the tail is pulled out. So you can see that right here where we could have skew or symmetry, and modality. This is modality right here because there's a mode. Or we have uniform, which is where there's no modes. Let's continue on. Which of the following best describes the center of the data? And since it's skewed, this is very important. This is so key. Since the data is skewed, it is the median, and the median appears to be in here somewhere. So let's see what our options are with median. It is going to be the median, and think about this. If you're averaging 2 numbers, you'd probably have to average something like 3 and 4. You can't get 3.2, and probably that's the answer for the mean. But since the data is skewed, we have to use the median, and the median is going to be the average of 2 numbers, and that is it right there. You could also put them into your calculator again if you want to double check, but remember, when the data is skewed, you use the median. When the data is symmetric, you use the mean for a measure of center. The spread of the data is blank to blank hurricanes. Nice and easy. Oh, I love the easy questions. 1, 2, 5. There we go. And use ascending order, not descending. There we go. Nice and easy one at the end there. Good job. Make sure to review over these parts, and good luck.